What is on midterm number 3?
Professor.
So you remember on the first midterm, there was a question which said, take a bunch of limits. Take the limit of this, take the limit of this, take the limit of this, and so on. And on the second midterm, there was a question which said, take the derivative of this, take the derivative of this, take the derivative of this, and so on. On the third midterm, there is going to be a question where you have to take a bunch of antiderivatives. So take antiderivatives using the antiderivative rules. And maybe some algebra. Remember, if it looks like there's no antiderivative rules that cover what you're doing, try a little bit of algebra first. And don't forget to put in your plus C. Don't forget the plus C. So that's one of the questions. I'm telling you right now, I'm not going to tell you exactly what I'm going to ask you to take the antiderivative of, because that would be kind of pointless. But I will tell you that one of the questions will be part A, it says just take the antiderivative, part A, part B, part C, part D, just a bunch of different stuff, take the antiderivative of. One of the questions will be applied max min. Make this as big as possible. Make this as small as possible. We did several problems like this, and you had a problem on your homework. There was we did a problem with Rancher. We did a problem with the box that you had to fold out of that piece of cardboard. We did a problem with taking a wire and bending it to a circle and a square. I think on your homework you had a problem with forming a circular cylinder and trying to maximize the volume of that. So an applied max-min problem. So don't forget the steps. Draw a picture. Define your variables. I would love to put a star next to this. I think I will. If you can get as far as this, drawing a picture and defining your variables, I think you have a really good shot at getting the rest. So remember, when you're defining your variables, one of the variables is going to be the thing that you have control over, and the other is going to be the thing that you're trying to make as big as possible or as small as possible. So number 3, write a formula for the thing you're trying to maximize or minimize. Or you need an interval. Now that you've, in 3 and 4, set up a max-min problem, solve the max-min problem. You know how to do that. We've done that earlier in the course. You find all the critical points, you get rid of the ones that are outside the integral, you plug the ones that remain plus both endpoints into the thing you're trying to maximize and minimize, pick the biggest or the smallest, whatever you're being asked to do. So 5 involves kind of a lot, and then 6, some sort of concluding statement. Include your units. In your answer. You do not have to carry units all the way through the problem. That's just messy. But when you get to your answer, make sure you put your units in. You know, meters or meters squared or, you know, dollars or whatever you're measuring things in. Okay. So we have a take antiderivative problem. We have an applied max-min problem. Estimate the area under a curve. Just not find, just estimate. So you're not going to have to do the thing where you let the number of subintervals go to infinity. I'll tell you, you know, 4 subintervals, 5 subintervals, whatever it is. Estimate the area under a curve using a right-hand sum or a left-hand sum. And I'll also probably ask you to tell me, is your estimate an overestimate or an underestimate? You'll have to look at your picture with the rectangles on it and tell me. Tell me whether it's an overestimate or underestimate, and you can tell me how you know. I mean, say, I'm looking at my picture, and here we are, here are the rectangles, they stick above the curve, overestimate. And one more question. What was the last question? Oh, yeah. So your definite integral rules. So those rules we did last time, like, you know, the area between here and here plus the area between here and here is equal to the area of the whole thing. I mean, these were intuitive rules. We had the integral of f plus g equals the integral of f plus the integral of g. We had the rule with a constant in it. We had like 5 rules altogether. 2 of them were for linearity. One was like this. The area under a curve between x equals a and x equals a is clearly 0. Those rules.
Are we just going to have to define the rules, or we're going to have examples where I have to apply them?
Use them. Use them. Yeah. Yeah, you don't have to quote the rule. I can't think of why that would be important in your life. But yes, just go ahead and use them. And that's it. That's the test. It shouldn't take long. I mean, I can never say exactly how long a test is going to take, because it doesn't take the same amount of time for everybody. But you're going to have an hour and a quarter again. Again, it's closed book, closed notes. Do it by yourself. If you get stuck and you need to ask a question, ask it of me. As I said, an hour and a quarter, including the time you'll need to upload the exam to the usual place, that drive that we share. I appreciated last time so many of you, instead of uploading the pages separately, put them all in the same file. That was extremely helpful for me when it came time to grading. And so hopefully you'll do that again. A lot of you named your file last time midterm number 2. That was also extremely helpful. I hope you'll name your file something like midterm number 3 this time. And yeah, that will be posted by 3 o'clock this afternoon, and that will be due Monday morning at 9 a.m. And I'll have the stuff, you know, I'll have those instructions posted online. So, what are your questions? How are we doing for time anyway? Oh, all right. What are your questions?
I had a question, but it wasn't about the midterm.
Okay.
Is the final during the finals week?
It is. The final exam is during the finals week. The final exam is cumulative. I can tell you a little bit about it right now. I'll tell you more about it next week. But the final exam is about 10 questions long, 10, 11 questions long-ish, with parts again. Figure a little bit more than twice the length of a midterm, but you'll have 3 times as long to do it. It really shouldn't be a race against the clock. However, it does cover the whole course. It's cumulative. And even though it shouldn't be a race against the clock, you know how it is. I know how it is. It can be grueling, like any exam can be that covers an entire course, but it shouldn't be only because the fact that you'd be sitting there for a while doing calculus, and that's the only reason it would be grueling. Let's see. As you know by now, don't try to scour the course for the most obscure stuff I could possibly find. I'll cover the highlights of the course. There will definitely be on the final a question where you have to do an applied maximum problem. That's one of the highlights of the course. That's definitely going to be there. The fundamental theorem of calculus, definitely going to be there. How could I have a final exam and not put the fundamental theorem of calculus on it? It will cover derivatives. You'll have to take a bunch of derivatives. The relationship between position and velocity and acceleration, that's got to be there. And you don't have to write this down now because I will go through this next week. I'll tell you, what the fair game is for the final exam. Again, that will be uploaded to the Google Drive that we share.
I had a question as well.
Yeah.
Is it possible to get our previous papers back before the final, so we know where we went wrong?
Yep.
Thank you.
Sure. What other questions do you have?
Is it going to be a self-scheduled exam, or is it you're going to release it this day and it has to be done that day?
No, it'll be a self-scheduled exam.
Okay, thank you.
It will definitely be a self-scheduled exam. I've never, unless there's something between you and the college which says you specifically, can't do self-scheduled exams. All my exams for finals are self-scheduled. But I think the self-scheduled exam, how long do you have? Is it a whole week this semester? Do you know?
Yeah, I'm
Okay,
pretty sure
so
it's a whole week.
whatever the exam period is, I'll post it as the exam period is starting, and then it has to be done by the time the exam period is finished. But again, there'll be a time limit on it, and I do that so I don't make exams that are incredibly long. That's just not fair. So there'll be, a regular 3-hour time limit on it, plus a quarter hour to upload your exam. But again, I don't think for the vast majority of people, it's going to be a race against the clock. That being said, as usual, the better you know the material, the faster you go as a person. Not everybody takes exams at the same speed, but the better you go in knowing the material, the less time you have to think about how to sort of work it out from scratch. The faster you can just jump into the questions. So what other questions do you have? Okay, well, I guess we have another 14 minutes left of the class, but I will hand that back to you. I guess I will see you all on Monday. I hope you have a good weekend. I hope the third midterm goes well. Again, closed book, closed notes, but if there is a problem with it, please feel free to ask me.
Thank you. Have a good weekend.
You too. Bye, everyone.